Model Solutions, Paper 2HR, Thursday, 7th of June 2018. So, question 1. We have three numbers written in order of size, x, 10, and y. The mean of these three numbers is 11. And think about the definition of mean. The definition of mean is when you add up the numbers and divide by how many numbers you have. So if you add the numbers up and divide by how many numbers there are, which is 3, you end up with the mean, which is 11. So what I can do is I can rearrange this to work out what x plus y is equal to. So times both sides by 3, then you end up with x plus 10 plus y is equal to 33. And then subtract 10 from both sides. Now you know x add y must be equal to 23. Okay. Also, it tells you that the range is 7. The range is the difference between the highest and the lowest number. So y take away x is equal to 7. Now if I write that underneath it, so if I write, let's write it in this order, minus x and positive y is equal to 7. We have simultaneous equations here. If we add these two equations together, then the x's will cancel. So minus x add x, bye bye. Y add y is 2y. So 2y is equal to 23 add 7 is 30. And that means y is equal to 15. So now we know y is 15. We also know x add y is 23. So x add 15 is equal to 23, and that means x must be equal to 8. Next question. So we can draw a triangle if we like for pressure. The formula for pressure is force over area. Right, so the pressure is 42 newtons per meter squared. It wants us to work out the force, and it gives some information about the face of the box which is in contact with the table. So here's a box. Here's the table. So what we're interested in is the area which is in the shape of a rectangle that is in contact with top of the table. So what we're interested in is the area of this rectangle here, the bottom of the box that's in contact with the table. Now they tell us it's a rectangle which is 2 meters by 1.25 meters. So it looks like this, a rectangle 2 meters by 1.25 meters. So the area of the rectangle is length times width. 2 times 1.25 is 2.5 meters squared. So the area is equal to 2.5 meters squared. Force is equal to pressure times area according to the triangle. So it's 42 newtons per meter squared multiplied by the area, which is 2.5 meters squared. Now this is fine to multiply these two numbers together because the units are consistent. Okay, one of them is newtons per meter squared, the other one is in meters squared, so that's absolutely fine. 42 times 2.5 gives you 105 newtons. That's good. Next question. So we have some candles, 6.3 kilograms. Let's just highlight the key parts of this sentence. She has 6.3 kilograms of wax, and uses 210 grams of wax per candle. Sells 2/5 of the candles for $13 each. She then reduces this price by 20% and sells the rest of the candles. Okay, so first of all, I guess the key thing to spot at the beginning of this question is the units are consistent. What we need is the same units. So for the wax, there are 6.3 kilograms of wax. Now, there are 1,000 grams in a kilogram. So if I convert 6.3 kilograms into grams, I can multiply 6.3 by 1,000. And that will give 6,300 kilograms. So that's how many kilograms of wax she has. Sorry, how many grams of wax she has. If I want to work out how many candles she's going to make from that, then I can divide that by the weight of each candle, which is 210. So 6,300 divided by 210, and that gives me 30 candles. Okay. So she's going to sell 2/5 of the candles at £13 each. So what is 2/5 of 30? Well, just type in the calculator. 2/5 times 30 is equal to 12 candles. Obvious times the maths, remember. So she's going to sell 12 candles at $13 each. So 12 times $13 gives her $156 income. She then reduces the price by 20% and sells the rest of the candles. Well, let's work out the rest of the candles. We have 30 to begin with, sold 12, 18 candles left. Okay? She's going to sell 18 candles at a reduced price. What price? Well, 20% less. Yes? So the candles previously were $13. If you want to reduce this by 20%, either you can work out 20% of it and take it off, or you can multiply it by 0.8, which reduces $13 by 20%. So 13 times 0.8 gives you $10.40. So she's going to sell the reduced ones for $10.40 each. Okay? So we have 18 times $10.40, that gives us $187.20. Okay, work out the total amount she gets by selling all the candles she has made. So that's the sum of these two. When you add them together, you end up with a final answer of $343.20. Next question. Expand and simplify. You can draw the list of lines if you wish. 3c minus 21 plus 6c plus 8. Oops. Schoolboy error there. Add them together and you end up with 9c. Okay. And if you're unsure about the number here, negative 21 and 8, just type it in the calculator. It will come up with negative 13. So the answer is 9c minus 13. Next question. Let's expand the brackets. First to first, first to second, second to first, second to second. So x squared minus 2x plus 7x minus 14. So x squared plus 5x minus 14. The next one, factorize, means to put into brackets. So 7 goes into 28 and 21. Also, there's a y that's common, so 7y brackets. What do you multiply 7y by? End up with 28y squared multiplied by 4y. What do you multiply 7y by to end up with negative 21y? The first thing that needs to be done on this question is to multiply both sides by 4. You do not like the divide by 4. So you multiply both sides by 4. Okay? And what happens is the divide by 4 on the left hand side cancels with times 4. On the right hand side you times everything there by 4. Now either you can write 4 brackets 3x plus 1, or you can just times them both by 4. I'm going to write brackets. So 7x minus 2 equals 12x plus 4. I have a double swap situation now. X's on both sides. You always deal with the least amount of x's. So let's shift 7x to the left and the numbers to the right. So we have 12x minus 7x, and on the left hand side we have a negative 2 and a negative 4, negative 6, 5x on the right. Okay, we want x on its own, so divide by 5. This is what you end up with. Now either you can leave it like this, or you can type it in the calculator. I always prefer the fraction, so just leave it like that. Okay, so divide to Rome. The flight time was 6 hours and 42 minutes. So we have the time, we have the speed, working out the distance. So the formula is sausages don't talk. SDT, sausages don't talk. Okay. To work out distance, we need to do speed times time. Now, what you must not do in this question, very dangerous, is to do 6.42 as the time. That's illegal. There is a button on the calculator that converts hours and minutes into a decimal, and that's the time button, which is this one here. So we type in 6 hours and 42 minutes. Yeah. Press equals, press S to D, and it changes it to 6.7 hours. So this is 6.7 hours. Okay, and that's what we need. So distance is speed times time. So 650 multiplied by 6.7, and that gives us 4,355. Next question. So compound interest, there's a formula for compound interest. You have your initial value multiplied by the multiplier. The multiplier is 1 plus x over 100 to the power of the number of years. So she has 20,000 rupees. The interest rate is 1.5%, so it's 1 plus 1.5 over 100. And it's all raised to the power of 3. Work out the total amount of money in the account at the end of 3 years. So if we type this in the calculator, we end up with 20,913.5675. And if you give your answer correct to the nearest rupee, that's the nearest whole number, so 20,914. Because the 5 makes the 913 round up. Okay, next question. Simplifying. Okay, so we have an x squared on the top and x squared on the bottom, which will cancel. 20 divided by 4 is 5. Y to the power 6 divided by y to the power 2 is y to the power 4. Next question, make E the subject of the formula. So subtract f from both sides. H minus f is equal to 3e. Then finally divide by 3. Okay, put one nice fraction line like this. Okay, all of this needs to be next, we'll draw a diagram to represent this one. From point A, Stanley walks 200 meters due east to point B. Due east. But from point B, so he's at A. At A goes to B, 200 meters. He then walks from B 160 meters due south to point C. Not drawn to scale. South. Okay, this is 160 meters. Work out the length of AC. This distance here. It's a right angle triangle. And we're working out this side. This is Pythagoras' theorem. Okay, so a squared plus b squared equals c squared. C is always the one opposite from the right angle. So it's 200 squared plus 160 squared equals c squared. 200 squared plus 160 squared equals 260 squared. 260 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 squared plus 160 squared equals Okay, and C is the square root of this. 200 squared plus 160 squared. Square root 200 squared plus 160 squared. What's this? 256.1249. Okay, and give your answer correct to three significant figures. So 256 is the answer to the question. Next question. Work out the size of angle x. Right. So I can work. Both of these shapes are regular here: regular pentagon, regular octagon. The internal angles, or the sum of the interior angles, is found by using this formula: n minus 2 times 180. N is the number of sides. So this shape has 5 sides. So 5 minus 2 is 3. 3 times 180 is 540. So all the angles in the pentagon add up to make 540 degrees. If I want to work out one of the angles in the pentagon, I do 540 divided by 5, which is 108. Using a similar method for the octagon, n is 8. 8 take away 2 is 6, and 6 times 180 is 1080, and then I need to divide that by 8. When I divide that by 8, I end up with 135. So 1080 divided by 8 is 135, so this is 135. In fact, they're all 135. But angles around a point allow me to work out this angle here. Angles around a point add up to 360. So I do 135 adds 108, that's 243. 360 minus 243 gives me 117. Okay. Now, what kind of triangle is this? Well, the diagram shows a regular pentagon and a regular octagon, and they share this side AB. They share that side, and all the sides on the octagon are the same, and all the sides on the pentagon are the same because they're regular. So all the sides of the pentagon are the same as all sides of the octagon, which means this is equal to this one, which means this is an isosceles triangle. And the way that you work out the base angles of an isosceles triangle is you subtract 117 from 180 and then divide it by 2. So when you do that, you're going to do with angle x, which is 31.5 degrees. Next question. Work out the size of angle x. So what I'm going to do first of all is I'm going to split this shape into a rectangle and a triangle. And I can work out the base of this triangle. So I can do 24.3 minus 16, which is 8.3. 8.3. This side is 12.5. Now, just because I've split this triangle does not mean I've divided angle x into 2. What I know is because this is a rectangle, on the left-hand side of the grey line is a right angle. So all I need to do is work out the angle inside the triangle at the top here, add it to 90, and that will give me angle x. So now, if I draw the triangle out separately, this is 8.3, and this is 12.5. And I'm working out the angle at the top, which is, I'm now going to use SOHCAHTOA or trigonometry to do this. Label the sides. This is the opposite, and this is the adjacent, which is found between the right angle and the angle. So it's tan, TOA, tan of the angle is equal to opposite, 8.3, over adjacent. Right? Now what you normally do is draw one of these triangles, the TOA triangle, TOA. And what I've done here is I've filled in the triangle, tan of the angle, tan of x is equal to O over A. You cover the t, and underneath your hand it will say tan x. So tan x equals 8.3 over 12.5, opposite over adjacent. What we need to do now is work out inverse tan, okay, of this fraction to work out the size of the top of the angle, top of the triangle. So inverse tan of this fraction, 8.3 over 12.5. Okay, and that gives us 33.584. Okay, etc. And then if I add that to 90 plus 33.584. Okay, this gives me 123.584. Okay, and then give your answer correct, one decimal place, 123.6, which is the final answer. Okay, next question. Write down the modal class. This is the class interval that contains the highest frequency. So 36 is the highest frequency, so we write down 100 is less than m, which is less than or equal to 200. Cumulative frequency, so this is like a running total. So we have 10 in the first row. The next row we have 36, we add that to the 10, we get 46. Just keep adding as you go down the table, 80, 100, 115 and 120. Now we're going to plot the points. We use the end points, and it's supposed to look like an elongated S-shaped curve. So we start here at 100. Okay, so 100. Have a look at the scale. 10 squares for 20. That means each tiny square is worth 2. Just bear that in mind. 100 goes to 10. 246, 40, 42, 44, 46. 300 goes to 80. 400 is 100. 500 goes to 115. So like this. 102, 4, 6, 8, 10, 12, 14, 16. So it's halfway. 115. 600 goes to 120. What we then do is draw a smooth, elongated, S-shaped curve through all of these points, and it must go through all the points. So it's up to you whether you start at 0 or whether you start at the first point and go to the last point. But it must go through all the curves, and it must be smooth, and it should have this kind of shape. Okay. Next, use your graph to find an estimate for the interquartile range. So interquartile range, what we need to do is draw some lines across. If we draw a line across at 60, this will work out the median. Median is the middle value. So if the median is at the 60th value, that means the lower quartile will be at the 30th value, and the upper quartile will be at the 90th value. So what you do is you draw lines across at 30 and at 90. Draw lines down, this is your working out. Okay, so we end up with something like this. This is about, each square is worth 10, so that's about 340. This is about 180. The formula for interquartile range is upper quartile minus the lower quartile. So it's about 340 minus 180. So 340 minus 180 is about 160. Next, use your graph to find an estimate for the number of families that spent more than £450 on holiday. So what we do is we find £450 on the x-axis. Okay. We draw a line up and we draw a line across. And read it off. There's about 180 there. Each square's worth 2. The question is, how many people spent more than £150 on holiday? More than 450. So we know there's 120 people altogether, not because the scale goes up to 120, because the cumulative frequency does. And there are 12 people above that, so 108 up to 120 is 12 people. So 12, that's fine. Next question. Okay, circle theorems. So read the information carefully. They're both tangents. A tangent and a radius meet at 90 degrees. So we can write down BCO is equal to BAO, and they're both 90 degrees. Okay, tangent meets radius at 90 degrees. It doesn't say to give reasons here, so you don't have to give reasons. Okay, we have a quadrilateral here, a kite shape, OCBA, it's a kite shape. In any quadrilateral, angles add up to 360. So if you add 90, add 90, add 74, subtract it from 360, we end up with 106. So angle COA is equal to 106. And finally, we want angle ADC, that's from A to D to C. And what you need to do is have a look at where the points start. The points start at A and C. If I go over this with my highlighter, we can start at A and go to O. We can start at C and go to O. That goes to the center point of the circle. We can also start at C and A and go to a point on the circumference of the circle, which is at D. And then you can see we have an angle at the center and an angle at the circumference, which means this angle must be half the angle at the center. Angle at the center is twice the angle at the circumference. The angle ADC must be 53. That's the answer to the question. Next question. So, the gradient of line L1 is negative 2. We'll write here M of line L1 is negative 2. The line L2 is perpendicular to the line L1. And the way that you work out the perpendicular gradient is to do minus 1 divided by the first gradient. So, like this, minus 1 divided by the first gradient, which is negative 2. That's what you type in the calculator. And it's half. So the gradient of the second line is a half. And it wants, what we're going to do now is we're going to work out the equation of line L2. We have the equation of line L1. We work out the equation of line L2. You can do that because the equation of a straight line is y equals mx plus c. So y equals half x plus c. And the way that you work out c is you need a coordinate on the line. So coordinates are always written xy. So we're going to substitute now to work out c. So it's 7 equals half of 4 plus c. Half of 4 is 2. So 7 equals 2 plus c. Rearrange this. 7 minus 2 is 5. So the equation of the line L2 is like this. And don't worry about the fact that it's called L2. You do not write L2 equals, you always write the equation of the line y equals mx plus c. They have just called it L2. They could call it Saffron the cat if they wanted to, but they've decided to call it L2. We just ignore that. Find the coordinates of the point where L2 crosses the x-axis. Well, let's just draw a little sketch for a moment. The graph crosses the y-axis at 5 because c is 5 and it has a gradient of a half. So it's, positive gradient. It's going to look something like this. Okay? We can work out where it crosses the x-axis, because at this point here, remember coordinates are always x, y. From the origin, we go along the corridor, question mark, don't know. But up the stairs, how many? 0. We go up the stairs to 0 because we don't move up the stairs. So the point that I'm trying to make is, when a curve crosses the y-axis, x is equal to 0. When a curve crosses the x-axis, y coordinate is equal to 0. So it's question mark, comma, 0. So let y equal 0. 0 equals a half x plus 5. Minus 5 for both sides. Minus 5 is equal to half of x. Okay, minus 5 is half of x. So what's a whole x? Well, double. Double a half, you get a whole one. Double negative 5, you get negative 10. It's negative 10, comma, 0. And the next question is to do with powers. And with 8. Okay, for this next question, we have 3 sets, A, B, and C. What you have to pay very close attention to here is this information underneath the table. It tells you that the numbers represent the numbers of elements. And this is very important because the 7 doesn't mean that it's just the number 7. It means that this 7 represents 7 numbers, but instead of writing the 7 numbers in this section, they write down the number 7 to represent the fact that there are 7 numbers. So the n in front of the bracket is also very important because it asks you how many numbers are in this section A union B. How many? So when you see 7, you know that there's 7 in this section and there's 3 in this section and so on. So what I'll do first of all is shade A union B. So the union between A and B is this section here. Okay, it's all of the A circle and all of the B circle. And if we add the 4 numbers inside this section, 7, 3, 8, and 1. So like this, 7, add 3, add 8, add 1. We end up with 19. The next section says the number in A complement and C. So not in A, not A, and in C. So let's use the highlighter. We're trying to look for the section now that's not in A, but it is in C. Not in A, but it is in C. Okay, and this should be quite straightforward, because since A and C do not overlap, it's always not going to be in A. It can't be in A and in C, because A and C do not overlap. So it's just going to be in C, which is 5, because you have 4 and 1. And the next one is not in A or not in B. Now this one's a bit more complicated. So what we do is, first of all, I'm going to highlight the section that's not in A. So not in A is everything outside the A circle. So not in A. Okay, so it's all of the numbers, it's all of the numbers here, not in A. Let's write these down. So we have 8, 1, and 4, and 9. And then it says, or not in B. So, the difference you see between or and and. So now I need to look at or not in B. So if I look at not in B now, just shade outside the B circle. Right. So it could be any of these numbers now. So I'm just looking at the numbers in the green section. Numbers in the green section are, we have 7, a 4, and a 9. Okay. Now, as you know with Venn diagrams, you're not allowed to include any numbers twice. So we can't include the 4 again, and we can't include the 9 again. So it's the rest of the numbers. So 8 add 1, add 4, add 9. Gives us 29 altogether when we add them all up. That's it for question 15. Next question. So there are 8 counters in a bag. There is a number on each counter. And what we need to do is consider the probability that her total is an odd number. Okay, so first thing that we're going to do is, if Fiona takes 3 counters at random, let's think about the ways in which you can add her numbers together to get an odd number. Now, what you don't want to do here is think about every number combination. The best thing to do is to consider what happens when you add odd and even numbers together. If you add 3 odd numbers together, probability of odd, 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 you end up with an odd number. And you can think about this in your head. Add 3 odd numbers together, you will end up with an odd number. Now, the probability of odd, to begin with, is how many odd numbers are there? 1, 2, 3, 4, 5. So there's 5 odd out of 8 numbers there, which means the probability of even must be 3 over 8. What we need to do is, first of one combination that will definitely work. She takes 3 counters and adds them together. So odd, odd, odd works. So the probability of odd is 5 over 8. Now the next time round, when she takes an oddball, it doesn't say anywhere that she replaces the counter. So you have to assume that she doesn't replace it, which means there'll be 1 less next time. So next time there'll be 4 out of 7 that are left. And next time there'll be 3 out of 6 that are left. And what we do is we multiply these probabilities together. Now, I'm not drawing the tree diagram, but when you times these fractions together, you end up with 60 over 336. This cancels down to 5 over 28, depending on whether you have used the calculator or not. Now, what about other combinations to end up with an odd number? Well, 3 evens will result in an even number. If you have odd, one even, again you end up with an even number. But if you have two even numbers and just one odd number, then you end up with an odd number. So we can have probability of even, odd. So one odd but two even. Now the odd number doesn't have to be at the end here. It could be even, or odd, even. That means we can times this by 3 because there's 3 different positions for the odd. You can work them all out separately. We can work out even, or odd, even. Or you can just work out one of them and times it by 3. So let's have a look at even to begin with. Probability of even is 3 over 8 to begin with. Next time, if you take an even number, there will be one less even number. So there will be 2 out of 7. And the third time, you want to take an odd number, but you haven't taken any odd numbers yet, so there's still 5 odd numbers left, but there's only 6 counters in the bag. Yep. And then what you do is you work this out, and then you can times it by 3. When you times it by 3, you end up with 90 over 336, or 15 over 56. Okay, depending on if you've used your calculator or not. And then what you do is you add the numbers together, add the fractions together, 5 over 28 and 15 over 56, to give the final answer of 25 over 56. Next question. Question 17, use algebra to show this is true. So, we start off by defining x. X is equal to 0.436 with 2 dots above the 3 and the 6. That means the 3 and the 6 recur. So another way of writing x is like this: 0.436, 36, 36, etc. Now, what we're going to do is we're going to consider different values of x. So we can consider 10x and 100x and 1000x. And that's because we have 3 decimal places here. So we can consider 10, 100 and 1000. We do that to begin with. 10x, you multiply this by 10. If you multiply it by 10, you end up with 4.36, 36, 36, etc. If you times it by 10 again, we end up with 100x. So you end up with 43.63, 63, etc. And times it by 10 again, you get 436.36, Now this is the long version of this question because you don't always need all of these. In fact, you only need 2 of these. But when you practice many of these questions, then you realise which ones that you need straight away. And what you do now is you look after the decimal point and look for the 2 that are exactly the same after the decimal point. So the 2 that match. The 2 that match exactly are 10x and 1000x. So what we're going to do here is we're going to subtract. We're going to write down 1000x is equal to 436.36, etc. And then 10x is equal to 4. Trying to align the decimal points as well. 4.36, etc. Now, when you subtract these, if you think about it, after the decimal point, you have 36, 36, 36, and the same thing on the next one. They will cancel because all the 3's will cancel, all the 6's will cancel because you have exactly the same decimal pattern after the decimal point. So they will cancel, and you're left with 990x. 436 minus 4 is 432. So 432 divided by 990 is the answer to the question. It's not their answer because they have cancelled it down. So what you need to do is just write x equals 24 over 55. If you type your answer into the calculator and press equals, it will cancel it down to this fraction, and that's the answer to the question. Next question is surds rationalising the denominator. Okay, when you see a fraction like this, what you need to do is simplify it. Okay, so you've got to be very careful not to use the calculator here, or use the calculator with great caution because you have to show. So we have root 20, and some of these surds can be simplified. Root 20 is the same as the square root of 4 times the square root of 5. You have two numbers that times together to make 20. One of the two numbers is a square number, so 4 is a square number. So you rewrite it like this. So when you simplify this, root 20 is 2 root 5. Root 80 can be thought of as two numbers times together. You may think of 4 times 20. Try to use 16 and 5 because 16 is a higher square number than 4. You should always use the highest square number. So it's the square root of 16 times the square root of 5. The square root of 16 is 4. And obviously that stays as root 5. Now on the top of this fraction, we have 2 root 5 plus 4 root 5. It's all over root 3. 2 root 5 plus 4 root 5 is 6 root 5. It's like 2x and 4x is 6x. 2 root 5 and 4 root 5 is 6 root 5. Okay, so we have a situation like this. And now what we need to do is rationalise it. We do not want a surd in the denominator. So what we do is we times top and bottom by the square root of 3. The same surd that's in the denominator. So on the top we have 6 root 5 root 3, which is 6 root 15. And in the denominator we have root 3 root 3, which is 3. 6 divided by 3 is 2, so we end up with 2 root 15. Now, normally this would be the final answer. However, they say let's express this in the form square root a, just square root a. Now, what I want to do for a moment is just consider something that I started off with. Let's think about this for a moment, because we have here 2 root 5, and the line before was root 4 root 5, and that was the same as root 20. So we know how to turn root 20 into 2 root 5. What about turning root 2 root 5 into root 20? Well, what you would do is you would write 2 in a square root, but you have to square it first. So 2 is squared to give 4, and that's in a square root. And then you times these two numbers together to end up with 20. So if I have 2 root 15, and I want to work backwards, well, 2 came from the square root of 4. And then root 4 root 15 is the same as root 60. So actually, root 60 is the final answer to the question. Now if you want to double check this, you just type in root 60 in the calculator, and it will tell you it's root 2 root 15, so they are the same thing. Right, next question. Simultaneous equations. Okay. So we're at the end of the paper. It's grade 8 to 9. Probably grade 9 this one is actually. And maybe grade 8. What we're going to do is use the method of substitution. They tell you what x is equal to. So what you need to do is where you see x in the non-linear equation, you need to replace it with this. So we end up with something like this. 2 brackets x squared, and x is 2y minus 3 squared, plus 3y squared is equal to 14. So the question is, how good is your algebra? Well, you should know that squaring means to multiply by itself. So what we're going to do now is write the brackets out twice. Now either you can do this as part of the equation here, or you can do it separately on the side. So if we do it separately, we have 2y minus 3 times 2y minus 3 Okay, let's expand the brackets. 2y times 2y is 4y squared. 2y times negative 3 is negative 6y. In the middle you have negative 6y, and negative 3 times negative 3 is positive 9. So we have 4y squared minus 12y plus 9. Okay, so we have 2 times this. Let's write it back. 2 times 4y squared minus 12y plus 9. And then just copy the bits above with plus 3y squared equals 14. Okay, now let's times this bracket by 2. So we have 8y squared minus 24y plus 18 plus 3y squared equals 14. Right, now I can do some simplifying now. I have an 8y squared plus a 3y squared, which results in an 11y squared. There's a minus 24y there. Now I know that this is a quadratic, and quadratics should equal 0. So if I subtract 14 from both sides, then it will make 18 take away 14 is 4. Okay, this looks like a quadratic in y now. So we write down our a, b, and c. We can factorise this, use the formula. So a is equal to 11, b is equal to negative 24, c is equal to 4. Okay, so let's use the quadratic formula. We'll back to write x then. So that's a classic mistake. Normally x equals, but this is quadratic in y, so it's y equals minus b plus minus square root of b squared minus 4 ac to use the quadratic solving mode on the calculator, depending on which calculator you have. So enter your a, b, and c. So 11 minus 24 is 4. So this is, remember, it's y. Y is equal to 2. Y is equal to 2 11ths. Okay. And now what you need to do is substitute to work out your x values. Okay. So if we substitute into this one, x equals 2y minus 3. So we need to do 2 times 2 minus 3 for x. And when you do that, you end up with negative 29 over 11. Okay. Obviously, it's horrible as a decimal spelling. And the other one for x is 2 times 2 take away 3. So we end up with 1. Make sure the examiner knows they match. Okay. There you go. Next question, bounds. Okay. So what we like to do here is write down a table, upper bounds and lower bounds. Okay. So the number 8.4 has been rounded to, or is now corrected to 2 significant figures. What we need to do is write down the upper and lower bound for this. It's correct to 2 significant figures. Now, let's explore in a bit of detail how you work out the lower bound and upper bound. We have columns. We have hundreds, tens, units, and then decimal point, and tenths. We have 100ths, thousands, and so on. Now, if a number has been rounded to the nearest 100, right, if it's been rounded to this column, then it can be half of 100, 50 either side. If it's been rounded to the nearest 10, or in the tens column, then it can be half of 10, which is 5, so it can be 5 either side. If it's been rounded to the nearest whole number, it can be half of 1, so half of 1, or 1 unit is 0.5 either side. If it's been rounded to the nearest 10th, then it can be half of 1/10. If you type that into the calculator, 1/10 divided by 2, it's 0.05. So it can be 0.05 either side. Now using a similar method, if we half 100, we get 0.005 either side. Similarly, for 1,000, it can be 0.0005 either side. Okay, so that's the method. Now let's have a look at 8.4. It's been rounded to two significant figures. Okay, we can see that the furthest it goes is to the tenths column, one after the decimal point. So it can be 0.05 either side. If you add 0.05 to 8.4, we end up with 8.45. And if we subtract 0.05 from 8.4, we end up with 8.35. 6.3, in a similar method, we add and subtract 0.05, 6.25, and 6.35. And 0.27 has been rounded to the hundredths column, so it can be 0.005 either side. That's going to be 0.265, 0.275, and we have 1 mark now. What we need to do is work out the upper bound for the value of A. Now, we have a fraction here, right? And when we have a fraction, we need to consider how to work out the greatest or upper bound of the fraction. So let's use this analogy of cake. Okay. Now just think about this one. You have a cake. We can have a large cake, so let's call that the upper bound of the cake. And we can divide it by saying a very small number of people. Okay, so we have a large cake divided between a small number of people. Okay, so let's just say we have 2 people. So everyone gets, well, both of them get half of the cake each. Okay, very nice. Look at that cake, very beautiful. Or the alternative is we can have tiny cake. Oh my god, tiny cake. Okay, so about small cake. We can divide it between those people. Everyone's going to get it wrong. So we can see this now as a visual representation. We have a large cake divided by a small number of people, or we can have a small cake and divide it between a large number of people. So which one should we go for if we want the upper bound? We want the upper bound, but clearly it's this option. We want the largest cake, but the smallest number of people to share it with. So that's what we're going to deal with in this question. We want the upper bound in the numerator and the lower bound in the denominator. The denominator is quite clear, it's just t. So we want the lower bound of t, that's 0.265. But then in the numerator we have difference, but we want the upper bound of the difference. So it's the difference between p and q. We want the greatest gap between p and q. So if you use the smallest value of q but the largest value of p, that creates the largest gap between them, the upper bound, 8.45. Take away 6.25. Type this into the calculator, and we end up with an answer of 8.30188667, etc. Give your answer to correct it 1 decimal place. So it's 1 decimal place, it's 8.3. Next, solve the inequality. Right, so what we do here is we factorize this, or we can use the quadratic formula to work out the roots of the equation, okay, the inequality. So, whichever method you prefer, either factorization or using the formula, we need to work out the roots. So the roots, okay, let's write it down clearly then. A is 4, B is -5, C is -6. formula, x equals minus b, plus or minus the square root of b squared minus 4 times a times c, all over 2a. If you use the class whiz calculator here, we can work out the roots. So menu, equation, polynomial, degree 2, and into your a, b, and c, so 4, negative 5, negative 6. And we end up with two roots, x equals 2, or x equals negative 3/4. Now, these are the roots of the quadratic equation. Roots. So I think that means. So, this is an x squared graph. It's a parabola. It has a bowl shape. What we're going to do is we're going to mark the roots on. So the roots are where the graph intersects with the x-axis. Negative 3/4 and 2. The graph has a bowl shape and it's a happy face because it's a positive x squared. It's like this. Okay. Now we're interested in greater than 0. Greater than 0 means when is the graph above the x-axis? When is the graph above the x-axis? What I'm going to do now is I'm going to shade the region where the graph is above the x-axis. So this bit here. If you like, it's actually all of this section here. And then this section here as well. When the graph is above the x-axis. Okay. It's only below the x-axis, so between negative 3/4 and 2. So to the left of negative 3/4 and to the right of 2, it's above the x-axis. So let's write this down. To the left of negative 3/4, that means x is less than negative 3/4. Okay? Or the other one is x is greater than 2. Now it's absolutely fine to leave your answers like this and you will receive full marks for this question. Okay. There is a way to double check this because the class whiz calculator also has a solving inequalities mode on it. So if we type menu, scroll down to letter B, inequality, degree 2, and identify which type we have. We have type 1, greater than 0. Enter your A, B, and C. So 4, negative 5, and negative 6. And the class whiz calculator also displays answers. X is less than negative 3/4, and 2 is less than x, which is the same as saying x is greater than 2. So we've now confirmed our answers. Class whiz calculator, we're nice and happy. We've shown all the working, so we're going to receive full marks. You just remember, this question is not designed to be answered just directly from the calculator. If you do that, there's no working demonstrated, so you won't receive any marks because there's no working. You have to show some working. Okay, next question is this one. So it says, on the grid above, sketch the graph of 2f of x. So 2f of x means, what are we doing? Well, we have, remember that y is equal to f of x. And just keep saying that to yourself, y is equal to f of x. So what is f of x? Well, it's y. Y is equal to f of x. What does it tell you to do in part 10? It says, draw the graph of 2f of x. So what are you multiplying by 2? Multiplying f of x by 2. But what's f of x? F of x is y, so you multiply your y by 2. So let's take a look at some of these key coordinates. Quick key points on the graph. Okay, ones where I put a dot. And what we need to do is double the y. If we read the coordinate is 1, 3. If we double the y, it becomes 1, 6. This one is negative 2, negative 1. If we double the y, it becomes negative 2, negative Same with this one. It's currently 4 negative. If we double the y, it becomes 4 negative 2. So like this. And then what we need to do is next one, y equals f of minus x. So what does this one mean? Well, it's slightly different because this time in the bracket the x has been replaced with negative x. So x has been replaced with a negative x. So what you do is you look at your coordinate x. This coordinate here is minus 2, minus 1. And you replace your x with a negative x. So instead of minus 2, it's now minus 2. Minus 2 makes positive 2. So it's positive 2, negative 1. And this one, at the moment, is 4, negative 1. So you replace your x with a negative x. So before it was 4, now it's negative 4. Now it's negative 4, 1, just on the side. And this one is 1, 3. So when you replace your x with a negative x, it becomes negative 1, 3. 3 dots. Join them up. Right, next question. Right, so I guess the first thing to spot in this one is the difference of 2 squares. Right? Lots of things that you can do here. You have the difference of 2 squares and the denominator can be factorised. Let's do both. So I'll have to factorise here at the top. There's not much space in this question. 5x squared plus 2x minus 7. How do we factorise this? Well, one way is to draw 2 sets of brackets. Because the equation starts off with a 5x squared, you can write 5x as the first term in each bracket. Now, of course, this is wrong, because 5x multiplied by 5x is 25x squared, not 5x squared. But don't worry, it will sort itself out in a moment. What we then do is we multiply the first number by the last number. Okay, and write a little note to the side. 5 times negative 7 is negative 35. We would like 2 numbers in the brackets that multiply to give negative 35, but they add to give the middle number, which is 2. Now these numbers that add to give 2 but multiply to make negative 35, numbers that times to make 35, 1 times 35, 5 times 7. Okay. We can use 5 and 7 to get the signs right. I want positive 2 when I add them, so if I have positive 7 take away 5, it's fine. What you then do is you then simplify the brackets if possible, okay, but avoiding decimals. So the first bracket divides by 5. If you divide it by 5, you end up with x minus 1. And the second bracket will just keep going. Okay, so here we go then. So the numerator here is the difference of 2 squares. 4x squared is the square of 2x. 25 is the square of 5. That means the brackets will be 2x plus 5 and 2x minus 5. In the denominator, we've already factorised this one, so we have x minus 1, and we have 5x plus 7. And we're going to times this by, now, what we can do now is make this one into a single fraction. So, again, I'm going to have to do this on the side here. Because you're subtracting these 2 fractions together. So what we can do is we can create a common denominator. So when we have a common denominator, we need at least both brackets featured in the denominator. So we have x minus 3 and 2x minus 5. And I'm not going to draw these lines, I think it's going to get very messy. But let's consider the first fraction here. What do you multiply to x minus 3 by to end up with this denominator? So what do you multiply x minus 3 by to end up with this denominator? You multiply it by 2x minus 5, so you times the top by 2x minus 5. And don't forget that this is minus. Okay, what do you multiply 2x minus 5 by to end up with multiply it by x minus 3. So times the top by x minus 3. Now, the rule is we expand the numerator. Expand. But we leave the denominator alone. Okay? Leave the denominator as it is. Okay? When you expand on the top, you get 4x minus 10. And then it's minus 3x. And just be careful here. Minus 3 times by minus 3, which is positive. So when you simplify your numerator, you end up with x minus 1. So now, we're going to times this by, what do we have? X minus 1 in the numerator. And in the denominator we have x minus 3, and we have 2x minus 5. Okay? Now these two fractions now are times together. That means we can cancel diagonally if we need to. What can we cancel? Cancel 2x minus 5 with a 2x minus 5. We can cancel an x minus 1 with an x minus 1. Anything else to cancel? No. So what we're left with, 2x plus 5 numerator. Oops. And in the denominator we have 5x plus 7 and we have x minus 3. Question. Okay, let's have a look at this vectors question. So there's no diagram provided. We can draw a diagram which may be of use to us. So vector OA equals A and vector OB equals B. OAB is a triangle. So let's just mark a point O. Okay. So just going to draw a random triangle. So this is point O. Let's call this A. Call this B. So vector O to A is A. And vector OB is B. Okay. Arrowheads are important. Okay, what else can I mark on? C is the midpoint of OA. Okay, so C is the midpoint of OA. Now, what I'm going to do now is I'm just going to adjust the diagram slightly. Because I know this is the middle, then this must be half of A. And this bit must also be half of A. Okay. D is the point on AB, such that AD to BDB is in the ratio 3 to 1. D is AB such that AD to DB ratio 3 to 1. Okay, that's fine. So it starts at A and ends at B. So D is somewhere sandwiched between. And it's divided into this ratio 3 to 1. So we imagine there's 4 parts here, and D is 3 of the parts through. So it's going to be about 3/4 down the line. So it's about here. We don't know what vector AB is, but we know that D is about there somewhere. So this is 3/4 of AB, and this is 1/4 of AB. Okay. Let's go in this direction. Right. What else can we mark on? That's fine. E is the point such that OB is equal to 2BE. So OB is 2BE. So what you need to do with this one is think about which vector is longer. Is OB longer or is BE longer? OB. So if you imagine, I'll write it on this. So you can think about this. OB. Now you should really think about lengths here, but it's just to illustrate the point. If OB is 10 centimeters and that's equal to 2BE, that means BE must be 5 centimeters because two BEs make one OB. So BE is half the length of OB. Because two BEs make one OB. So okay, so what it means is if BE is half of OB, it's about there somewhere. Okay, and that means this bit here must be half of B. From B to D. So my diagram's pretty good now. What I want to do now is use a vector method to prove that CD and E lie on the same straight line. So when you want to prove this, CD and E lie on the same straight line, you work out from the first letter to the second letter, and you work out from the first letter to the last letter. So from C to D, right? Let's go from C to D to E. Okay. Now this is a little bit complicated because I'm trying to find a route now to get from C to D. I'd like to go this way around, but the problem is I don't know what this part of the journey is from A to D, because all I know is it's 3/4 of this vector here, AB, but I haven't actually worked out AB. So I know it's 3/4 of AB, but I haven't worked out what AB is. Well, let's try and work out AB. Okay, so how do you get from A to B? Well, you're going to go this way around. So remember, you're going backwards against OA. So this is minus A, and then it's forwards with the arrow B. So it's minus A plus B, which we normally write as B minus A. So that's what vector AB is. And I know that AD is 3/4 of that, so it's 3/4 of B minus A. And also, this bit here is 1/4 of B minus A. But as long as you go in this direction, because remember, the vector B minus A is from A to B. So now I have everything I need to work out the vector CD. So to get from C to D, I'm going to follow this path. I'm going to go up here and then down this way. The arrowhead is very important. So it's half of A, and that takes me up here, and then plus, because I'm going up with the arrow, 3/4 of B minus A. Okay, so now let's expand the brackets. So we have half A plus 3/4 B minus 3/4 A. Now if we type this into the calculator, all we can do is type in, we can simplify the A terms. So half of A minus 3/4 of A is minus 1/4 of A. So we end up with something like this: 3/4 B minus 1/4 A. Okay, now this can be factorised. Okay, the quarter is common, so we have a quarter brackets 3B minus A. Okay, and I also said that we need to work out from the first letter to the last letter. So we worked out from C to D. We're now going to work out from C to E. The easiest way to get from C to E, down here and across. I've labelled my diagram very nicely. It should be quite easy. Remember, I'm going backwards now against the vector, so it's minus half of A to begin with, and then all the way down to the end. So B add half of B. If you add B add half of B, that's 1.5B or 1.5B, or if you like fractions, 3/2B. All I've done there is I've typed it into the calculator. 1 add a half. If you do that, it's 3/2. Now we don't normally write it like this. Normally we write it. So we have the negative sandwiched between. It's very nice. So we have 3/2B minus half of A. What I want to do is factorise this because I can. There's a half that's common. 3B minus A. Now, what you need to do now is compare CD with BE. Oh my gosh, they both have the same bracket. But what do you do to vector CD to make it vector CE? Because that's 1/4 of this, and that's half of this. So 2/4 make a half. So if you double this one, if you double CD, if you do 2 times CD, you end up with CE. So 2 of this vector make one of these. Okay? And also there's a common point. There is a common point D. This is now worth 5 marks. And the last question on this paper, the grade 9 question. Right, what we're going to do here is, this is called completing the square, but it's very awkward because there's a negative x squared, so we can deal with this straight away by factorising it, taking a negative out. What we do is we invert the signs on all the terms, so negative x squared becomes positive x squared, negative 4x becomes positive 4x, and 7 becomes negative 7. Then what we do is complete the square inside the bracket. So when we complete the square, we'll get x plus half of the coefficient of x, which is 2 squared. Then we subtract the number in the bracket squared, so 2 squared is 4, and then we copy the number at the end, negative 7. What we then do is simplify this inside of the brackets, so we end up with x plus 2 squared, negative 4 taken by 7 is negative 11. And then finally, we apply the negative to the bracket. So a negative and the bracket will make negative x plus 2 squared. It doesn't affect the inside of the bracket. And a negative 11 will make positive 11. Look at the way that they have presented the answer. It's p minus the bracket squared. That's because we should always sandwich the minus. So it's going to look like this. Now it doesn't ask for the turning point, but just for fun, the turning point is the number in the bracket with the opposite sign, and the number on the outside with the same sign, so negative 2. Now we're quite directed by in part B, because it tells us to use the answer to part A to help us. Now you need to compare this expression here with this one, and look at the difference between them. Well, what's happened is the x has been replaced with y plus 3. So it's exactly the same, well, apart from the equals 0. But the x has been replaced with y plus 3. So we know that this expression at the top can be written in this format: 11 minus x plus 2 all squared. So what we're going to do is we can, if 7 minus 4x minus x squared can be written in this form, then so can this one, because it's basically the same. The only difference is the x has been replaced with y plus 3. That's what I'm going to do. I'm going to use my answer to part A, but as well as that, I'm going to replace the x with y plus 3. So I'm going to rewrite it as 11 minus, and then replace the x with y plus 3. Copy down the rest of it. It's 2 squared. It also equals 0. So when we simplify this, we end up with 11 minus y plus 5 squared equals 0. Now how to solve this? Well, you might be quite tempted to expand the bracket, but I'm not going to. What I'm going to do is I'm going to add the bracket to both sides, so you end up with something like this. And then I'm going to square root. So if you square root both sides to get rid of the square, you get plus or minus root 11 is equal to y plus 5 squared. Sorry, just y plus 5, because you have square rooted both sides. Then what you need to do is subtract 5 from both sides, and you end up with minus 5 plus or minus the square root of 11. And this is the answer, you see. It's e plus or minus root f. So e must be negative 5, and then f must be 11. Okay, these are called the roots incidentally. Now, the curve C is given here. The point A is a maximum point of the curve. So this is a negative x squared graph. If you expand the bracket, you get an x squared in there. The negative makes it a negative x squared, which means it's this kind of shape. Sad face. That's why it has a maximum point rather than a minimum point. Write down the coordinates of A. So what they're asking for essentially is the turning point. Okay, what's the turning point? The turning point is the number in the bracket with the opposite sign, the x coordinate, and the number on the outside with the same sign. Now, it's just 3. What the -5 does is it stretches it, but it doesn't affect the turning point. Okay? So it's just this. This is the translation part of it. There's 3 of them. This is a stretch to